Hello. So we're almost done. This is the last topic in this notebook. So we've been talking about covalent bonds, which are sharing of electrons. So what this talks about is the idea of polar and non-polar covalent bonds. So if we think about the bonds we've talked about before, we've got ionic, we've got covalent, and now we've got non-polar and polar. So it's not two new types, they're just more specific types of covalent. So they're covalent bonds, so we still have sharing. So if we think about poles and we think about like a magnet, so if I were to have a magnet, I have a north pole and a south pole, right? And they have charge to them, right? And I can't attract a north to a north, they'll repel each other, but I could attract a north to a south end if I put two magnets together. So that idea of having poles or charged ends of a magnet, so you would have a positive end and a negative end. So that's the idea we're going to talk about here with polar and non-polar covalent bonds. Polar is going to mean that it has a positive end and a negative end. Now, it's not the same as ionic. It's not that they're giving electrons and it's a completely positive ion or completely negative. They're sharing, but they're not sharing exactly evenly, so it's a little bit lopsided. So it's a little tiny charge. Whereas nonpolar is not going to be charged. They're going to be shared evenly. Okay, so let's think about this. So nonpolar is the idea that we don't have poles. Oops, poles, sorry. Okay, so no poles. So in other words, the electrons in the covalent bond are shared equally. Okay, so that's the key idea. So in other words, each atom has an equal attraction for electrons. So in other words, one atom is not any sexier than the other. So when we're talking about attraction for electrons, remember that's electronegativity. So that's that value that we look up on the table. That's our attraction for electrons. So the only atoms that are truly nonpolar are the ones that are diatomic. Those are really the only true nonpolar covalent bonds. So let's take, for example, that we have chlorine. So we have chlorine that has 7 valence electrons. And we have another chlorine with 7 valence electrons. They're going to share these so that they have their 8. So what I'm going to do to figure out about the polarity is I'm going to look up their electronegativities. So remember that you look up electronegativity on table S, I believe, the back table. So if I look up the electronegativity for chlorine, it's 3.2. So that means this end of the bond is 3.2 and this end of the bond is 3.2. So that's how much they're attracting these electrons. So there's like this tug of war that's going on between these two, and the chlorines are pulling them back and forth. But since they both have the same attraction for those electrons or the same pull, they're shared equally. So we don't end up with any kind of positive or negative. Okay, so these are going to be shared equally because there's an equal attraction for those electrons, or an equal pull. Okay, so one of the atoms isn't more attractive than the other. Okay. When we're talking about polar covalent bonds now means that we have a positive and a negative pole. So that means that there's an unequal sharing of electrons. So when we're thinking about electronegativity, that's our measure of attraction for electrons. So in other words, they're going to have an unequal, okay? So in other words, the more electronegative will pull the electrons toward it. Okay. So if it has a greater attraction, it's going to pull it. So if we were to look at this scenario, if this one had been 4 and this one only 3.2, these wouldn't be shared evenly. They'd be being pulled this way. So you'd end up with more negative toward this end and positive toward that end. So what we're talking about is if we look back at the front cover, this was ionic, metal and a nonmetal. It was giving an electron. So completely positive ion, completely negative ion. This would be an example of our nonpolar. These electrons are equal pull, being shared evenly. So it's nice and symmetrical, shared evenly. What we're talking about now is when I have two things where one is more attractive than the other. So they're pulling these electrons a little bit more. They're not sharing completely evenly. So when they pull the negative toward them, they end up with this little bit of a negative charge and a little bit of a positive charge. So it's not a full negative, not a full positive like ionic. It's this partial negative and partial positive. Okay. All right, so let's take a look at some of these. All right, so which of the following bonds is most polar? All right, so if we look at oxygen, oxygen is diatomic. So we know from up here that diatomic is non-polar. So let's go ahead and draw it out and see why. So we have oxygen with 1, 2, 3, 4, 5, 6. We have another oxygen with 1, 2, 3, 4, 5, 6. So they're going to share and they're going to share. Okay, so we've got a double bond. If we look up the electronegativities, both of them have an electronegativity of 3.4. So oxygen, oxygen, 3.4, they're going to equally share. So we're getting nonpolar. Okay. All right, so now let's see what's happening with something else. All right, so HCl. So we know they're covalent because that's what we're working on this page. Hydrogen's a nonmetal, chlorine's a nonmetal. So we have hydrogen with 1. We have chlorine with 7 valence electrons. So they're sharing. So then you need to go and look up what their electronegativities are. So when I look up their electronegativities, hydrogen's is 2.2, chlorine's is 3.2. So chlorine has more attraction for the electrons. So what's going to happen is that these electrons are not being shared equally. The chlorine's like, nah, I'm a little bit sexier, so I'm gonna take these and give you a little tiny bit of that charge, but I'm really gonna be stealing them. So what ends up happening is because these are negative and the chlorine's pulling them a little bit toward it, not sharing entirely equally, this side ends up with a little negative charge, and this side ends up with a little bit of a positive charge. So because they're unequal share, we are going to consider them to be polar. And to find which one is the most polar, we see how big the difference is between those two. So chlorine's is 3.2, hydrogen's electronegativity is 2.2, so it has a 1.0 difference. So we'll compare that when we get to the others. Okay. All right, so let's look at the next one. Actually, we'll go over to HBr just before we get to a harder one. So HBr is going to be similar to how we did this, right? So we've got H with 1. We got bromine with 1, 2, 3, 4, 5, 6, 7. They're going to share. So if you had to guess, this one has 7. It's going to want to attract that electron more than the hydrogen because it's got 7. It really wants the one more. If I look up their electronegativities on the table, Hydrogen, we know from the last one, has 2.2. Bromine is 3.0, so it's not quite as sexy as the chlorine was, but it does have a lot of attraction. So bromine has a stronger attraction for electrons than hydrogen. So it's not going to share these evenly. It's going to be pulling it a little bit more toward the bromine. So bromine will end up with a little negative charge, and this side will end up with a little positive charge. Okay. So the bromine, it has more attraction for electrons. So there's an unequal sharing. So we know that that bond is polar. And then to see, again, which one is the most polar, we see what the difference is. So bromine was 3, hydrogen was 2.2, so the difference is 0.8. So far, this one, the 1.0, is more polar than the HBr. All right, and then the last one, we have NH3. So nitrogen is 5, and hydrogen has 1. So I'm going to go ahead and draw it bigger down here. 1, 2, 3, 4, 5. So we have 1 hydrogen here, 1 hydrogen here, and 1 hydrogen here. So we've got 3 bonds. They're all the same bond, nitrogen and hydrogen. So if we go ahead and we look up hydrogen's electronegativity, we know is 2.2. So I'll just put it on each one of these. And nitrogen, if we look up, is 3.0. So each one of these bonds, the nitrogen is pulling it a little bit more toward itself and not sharing it evenly, because this one is more electronegative, has more of an attraction than the hydrogen. So each one of these is getting pulled a little bit in. So that right here around that nitrogen is going to be a big negative, partial negative. And each one of these hydrogens is going to have a little bit of a partial positive. I know it's kind of messy looking, a little tricky to understand, but so there's going to be an unequal sharing between the nitrogen and the hydrogen. So that tells us that it's polar. And the difference is 3.0 for nitrogen minus the 2.2 for the hydrogen, which gives us a 0.8 difference. So as far as most polar, it's going to be our HCl. Biggest difference in their electronegativities. Okay. I know that's kind of a lot. Polar and nonpolar is a little tricky. It's not a huge concept that will be covered on the Regents exam, but it is something that you'll see. So I wanted to make sure that you are at least a little bit familiar with it. Take your time, stop this video, each one, maybe go back to just absorb it a little bit. But it really just has to do with the difference between those electronegativities and how evenly or unevenly they're sharing those electrons.